Oh! It's a funny word, but it's serious business.
Most of us don't give much thought to the water that leaves our homes.
But it's a good thing some people put a lot of thought into it, because dealing with our wastewater is a big job and extremely important.
To learn more about wastewater treatment, we visited the Coffee Creek Water Resource Recovery Facility, which serves Edmond, Oklahoma. Jennifer and Ruben from the Water Resources Department showed us around the facility.
And there was a lot to see.
We started the tour in the office building, where we got an overview of the process and started to get a sense of the massive infrastructure involved.
The first step in processing all the wastewater is collecting it.
The city of Edmond has almost 100,000 residents and 37,000 households. Those numbers are expected to grow 30% in the next 20 years. Of course, in addition to the homes, there are schools, businesses, industry, hospitals, hotels, recreation centers, and all of the other things associated with city life. All of these homes and places generate wastewater and are spread out over 90 square miles. A network of miles and miles of sewer piping run under the city. 8 lift stations pump the wastewater to the Coffee Creek facility for treatment. Hills and valleys cover the city of Edmond, so gravity can't move all the wastewater.
And that is where the lift stations come in.
From the outside, lift stations don't look that big, but they actually go 4 stories underground. This is the bottom level of the Coffee Creek lift station. On one side of the wall is a huge collection tank. When the level reaches a certain height, transfer pumps start pumping the raw sewage toward the treatment plant. Keeping these lift stations operational is a major priority, so each station has a backup generator and redundant pumps. The valves, pumps, motors, levels, flow meters, pressures, and generators are all monitored from a control room at the main office.
We will show you more of this control room later in the video.
Because this lift station is at the treatment plant, it has some additional equipment outside. These devices take out things like rags, flushable wipes, even fruit stickers. Everything that goes down your drains has to come out somewhere. If it doesn't, that is bad news because it means something's clogged. That is why you should be careful about what goes down your drains. Most of these are flushable wipes, and they might be flushable, but they don't break down like toilet paper. Toilet paper takes 30 minutes or less to decompose in water. Flushable wipes take more than 80 days to decompose, far longer than the 1 to 2 days of the whole wastewater process from the time it leaves a house to being fully treated. So the treatment plant has to mechanically filter these things out and send them to a landfill. You'll see more of that in the next step too.
The Headworks is the receiving point for all of the wastewater.
How long it takes the wastewater to get from a house to the Headworks depends on how far away it is. The travel time from the furthest houses is about 20 hours. Most of the houses are about a 3 to 4 hour trip. This leads to interesting yearly events that are highly predictable, like a big uptick in flow to the plant 3 hours after the halftime of the Super Bowl. Ruben explains what happens here at the Headworks.
All the flow from all the lift stations comes through this area right here. This area then we've got a trough that runs through here, and then we're able to split it between 2 units with the future third going to be right here. Next expansion, hopefully 20 years from now. So we have grid unit 1, 2 is not here, 3. Grid unit 1 is down right now, so let's go take a look at grid unit number 3. So first process we have So nothing's been processed yet. First process we have is a step screen. Step screen's going to pull out all those rags that I remember telling you guys about. That's all the rags. All those flushable wipes, cleaning rags. That's all of them right there.
These step screens are based on a clever operating principle. The water is flowing through a channel and through these screens. As the screens get covered up with material being filtered out, water flow gets blocked and the water level in the channel begins to rise. A level sensor detects the rising water and knows to step the screen up, moving the material to an auger for removal and rotating in a portion of the screen that has had the material removed.
Next comes the grit removal.
Water flows through the grid unit or through the step screens, comes into another conduit channel right here, and flows into our vortexes. These are giant cones where the water comes in on one side, starts to circulate, all the heavies fall to the bottom, water goes over the top. Water that and the grit that goes to the bottom is then pumped up, pumped into these units. These units are full of grit. There's a stirrer in there that keeps it liquefied. And then once it starts settling, the auger catches it and pushes it down to the blow-off tank. That is our grit.
Pushes it down to what?
It augers up and pushes it down to big blow-off trash cans. And we're going to take a look at that here.
We went down a level to see the material that was being removed at the Headworks. This material is headed for a landfill, but only after testing verifies it is safe for disposal.
This is the material that comes out of that. That being grit, it looks like sand, and then that being all those rags that we had. We go look at the other side of it. Here's a good picture of our crew. It's kind of got a black look to it. And it's just the sand. And then that's those rags that you saw on the step screen. Those are all those washable wipes and disposable. They are, but they're not.
One of the things that you notice at the Headworks, and the entire facility for that matter, is the lack of bad odors. Only the roll-offs had a smell, and it was minimal. That is possible because of the sophisticated charcoal filtering of the air. Leaving the Headworks, the wastewater now enters selector basins.
Comes right into this channel. Now this channel also has RAS, the recycled bugs that we pulled off the bottom of the clarifiers.
Time out. Let's talk about these bugs.
The bugs that the treatment plant uses to break down waste and clean up the water are all naturally occurring bugs. The plant just maintains a higher concentration of these bugs than you would normally find in the wild. They fall into two types. One type are anaerobic bugs, bugs that thrive in low oxygen environments. When Ruben talks about the low DO, he's talking about low dissolved oxygen. And those are the bugs that work in this stage, which are taking out nitrogen in the wastewater. The aerobic bugs, bugs that thrive in oxygen, we will talk about in the next stage. Also, when he's talking about red and green pumps, he is referring to the pump symbols in the control room.
Okay, back to Ruben.
Also come in here. So it's going through the process again to either maintain or increase those microorganisms that we need. Common channel. It then dumps into what we call our denitrification zone. What this zone does is it basically drops the DO. There's very little movement. You see hardly any air going into it. What we're trying to do is drop the DO so those bugs that like that the no DO are the bugs that eat nitrates, nitrites. Yes?
Is it just me or do I see small world basically?
It's what it is we do have a pump. If you look at this side, remember those pumps we saw that were green and red? And I told you you can see them and you can't see them? That's one you can see right there. All that's doing is just keeping just enough movement so it doesn't go septic.
Yeah, I keep seeing.
Yep. More of those mixer pumps that we saw on that board where that was green and red. Green being they're off. Step over here and desinfection. You can see we've got these 4 areas just with the wall in between them. It's just the flow comes in and then gradually just goes over each one. Once again, we want to keep the DO levels low. One DO or even, I mean, a little higher, a little lower, it's not gonna matter. But what we're trying to do is, once again, have those bugs that love the low DO and love to eat, we have them do it here. The bugs that like the high oxygen and are happy at high oxygen then go to our aeration basins. So once it flows through here, we go to aeration basins. So we've got the bugs that don't like high DO, and we got the bugs that do like the high DO. Bugs do different jobs. So we try to keep all the bugs happy here. So select your basin.
As you probably suspect, the oxygenation ditches are where the aerobic bugs thrive. One of these aerobic bugs are called water bears because they resemble a bear and love the water. They also eat and break down organic matter. Maintaining the right population of bugs is a key part of this process. In cold weather, you need more of these bugs because they are less active. In hot weather, they are more active and you need fewer of them. If there aren't enough bugs, the waste isn't broken down fast enough. If there are too many bugs, then there isn't enough food for them and they die off. Baby bugs and old retiring bugs don't eat as much, so having the right age of bugs is important too. To manage this bug population, samples are taken and tested right here at an on-site lab. The ditches you see today are in the process of being upgraded from a rotor system to an air diffuser system. These aerators are just here temporarily while the air diffuser system is being installed.
Things, oxidation ditches, which I think you seem interested in. We've got 2 sets that you see right now they're doing a bunch of work on. And what we're doing is we are going from a rotor system, which Jennifer showed you, those rotors that actually spin, they're agitating the water and we're trying to force air down 15 feet. That's how deep these ditches are. Well, gravity doesn't help. Gravity wants to push that air up. So what we're doing is, with this new process, we're getting a blower building, which is this building over here to our right. And what that's going to do is force air through this series of pipelines and piping that you see. And we're putting diffusers at the bottom. So now we're going to have air coming from the bottom up instead of trying to force it down. So we're going to have a lot more uniformity inside those ditches.
So what is happening in this stage of the process is the water is being made rich with oxygen, currently by mechanical means, but soon to be upgraded to a pneumatic aeration system. That keeps the bugs happy and active, and the slow winding path gives them time to work on the waste in the water to break it down.
In the next stage, the water goes through the clarifiers.
Now, from this point on in our tour of the treatment plant, we were limited by what we could see. The night before our visit, there'd been a big rain, and mud made getting close enough to film these stages impossible. Thankfully, Reuben and Jennifer were great teachers and described it all to us. Just be aware that some of the images shown may not be from the Coffee Creek treatment facility. The water entering the clarifiers have the solids from the bugs suspended in it. The clarifiers are large settlement tanks where the water is held still, allowing the solids to fall to the bottom. Scrapers automatically remove the solids from the bottom. Clear water flows out the top of the clarifier through weirs. Water passes through multiple stages of clarifiers. The solids that are removed from the clarifiers have a population of bugs. It gets sent out as either return activated sludge, called RAS, or waste-activated sludge, called WAS. The RAS goes back into the process after the Headworks to maintain a target bug population. If no additional bugs are needed to maintain the target, the sludge goes to the WAS route and is pumped into the lagoons. Eventually, what collects at the bottom of the lagoons is nitrogen and can be applied to farmers' fields as fertilizer after it has passed safety test, of course.
2 years, and then we will haul it. We'll have a contractor come in, and they will haul it to farmers' fields. And basically, by that point in time, it's broke down to where it's nothing but nitrogen. We do test it, and we get our testing from a separate lab, so there's no issues about it, and that way we can meet, as long as we meet the EPA and the DEQ standards, then we can haul it off to the fields. Yes?
So, true or false, there are no electronics here.
Water exiting the clarifying stages passes through sand filters as a final filtering process for any solids that have not been removed. The sand media is similar to sand filters used in swimming pools. It lasts a long time because the upstream process is so efficient at removing solids.
Next is the contact basin, where chlorine is introduced.
Chlorine acts like bleach, killing any bacteria in the water. A raceway path for the water gives the chlorine time to work. Leaving a concentration of chlorine in the water wouldn't be good, so after it has had time to work, sulfur dioxide is added to react to the chlorine and deactivate it. As part of the upgrades in progress, the chlorine and sulfur dioxide disinfection treatment will be replaced by an ultraviolet light disinfection process. This will make the process all natural. About 24 hours from the time the wastewater entered the treatment plant, it is discharged into Coffee Creek. That may sound a little suspect given the condition of the water when it came in, but here is one of the most important points about this whole process. The water that the facility discharges into the creek is tested daily to make sure it is cleaner than the water flowing upstream of this plant. Yes, the water discharged from the treatment plant is cleaner than the water already flowing in the creek. And just how much water is discharged per day? About 8.5 million gallons every day, all year long. That amount of water would be all of these things combined. 720,000 toilet flushes, 90,000 showers, 90,000 laundry loads, 37,000 dishwasher loads, and 10,000 baths.
And that still leaves 2.5 million gallons for business and commercial use.
That may be a little easier to visualize as one big volume. 8.5 million gallons is about the same volume as this 12-story hotel in downtown Oklahoma City. It's that much water every single day. But once the upgrades are made, the facility will be able to process 16 million gallons a day. Plus, expansion room will be in place to add equipment and additional lines to handle 20 million gallons a day, which should accommodate Edmond's wastewater needs for many decades to come. That is a lot of water, and gravity does some of the work, but pumps are required too. And because each stage has multiple lines of operation, and sometimes things can be directed to alternate places, and there are redundant systems, that means there's a network of manifolds and valves in the distribution system. A tour of the pump house shows many pumps and variations in sizes. The system utilizes pressure sensors, actuators, flow meters, and other monitoring equipment to ensure proper operation. That is a lot of infrastructure and a lot of activity going on. Back in the main office, there is a centralized control room that lets the operators monitor these widespread operations. This wall of large monitor screens shows equipment and process statuses and camera views to all locations. You can even see weather station data because things like rainfall and temperature are important to the operators.
Clarifying screens are that grit removal that we talked about is this machine, this operation right here. These screens, we have lift stations. Our lift stations up on the screens, so we have multiple. We don't have all of them cut over to this program, but just about everything. Selector basin that we talked about is right here. And then we have our recycle. This is where our RAS and our WAS that Jennifer was talking about, we're able to push that through the plant. We'll talk about that once we get down there.
All of the communications take place over a fiber optic network, even to the remote lift stations. Operators maintain a whiteboard for communications and prioritizing to-do list. The control room is a sophisticated and comfortable environment, but the operators have to do their inspections, repairs, and maintenance in the field. Hot or cold, rain or shine, on call 24/7 for 365 days a year to keep things running.
On-site laboratories are used for all sorts of testing.
Samples are taken from Coffee Creek upstream of the treatment plant to establish baselines. Remember, the water that the plant discharges must be cleaner than what is naturally flowing in the creek. Of course, that means that samples are taken from the water being discharged into the creek, too. Samples are also taken at key points in the treatment process to ensure that everything is working properly and to make management decisions on the bug population. They even have a separate lab that supports the drinking water treatment plant at nearby Lake Arcadia. Lab Director Mickey showed Alex how they test water hardness.
And then we add a chemical
That's
to
called
the water sample.
So, the vortex is called a whirlpool. That's what I know.
Yep.
Yeah.
I don't want to get it spinning too fast because it can actually throw the stir bar completely out. Yeah.
It just looks like the smallest and fastest
Yeah.
whirlpool.
And then we add what's called a chemical titrant. We measure the amount that we're putting in until this color changes and reaches a deep purple.
So, is too high bad?
Huh?
Is too high bad? Ah. So that's deep purple. It always makes noise.
Yep. So the water today is 142.3 milligrams per liter total hardness. And that's calcium and magnesium in the water.
These labs undergo a regular certification process and must maintain detailed records and documented performance to stay in compliance.
So we have to test just the general chemical characteristics of the well water in this laboratory. In that laboratory, the only samples we test in there are drinking water samples, and that's for microbiological testing. So we're looking at total coliform bacteria, E. coli bacteria, and heterotrophic plaque bacteria. And I believe we're only about one of 6 city-owned municipal labs that's actually accredited to conduct our own microbiological testing and report it to the EPA and DEQ.
So other cities would have to send it to a different
They haven't
lab.
sent them off. We used to in the past, yeah. But we do all that in-house now.
The Water Resources Department must be in compliance and in communication with several agencies, including the Environmental Protection Agency, the Oklahoma Department of Environmental Quality, the Department of Homeland Security, OSHA, and the local fire departments.
Woo! That was a lot of information.
It sure was. We left with a whole new appreciation for the work that goes into taking care of the wastewater we all generate. The technology, engineering, and work that goes into it all is impressive. But the most impressive part is the passion and dedication the staff puts into their work.
That is something to think about the next time you flush a toilet. Thanks for watching and see you next time.